Hey guys, today we are doing 7.8's notes, which is all about factor and solve. This is the very last section of chapter 7. It's also kind of a review section because all of this stuff we've already done before, we know how to do. It's just kind of taking a day to make sure we reconnect with how we know how to factor, and that translates to how we know how to solve. So each of the 4 different boxes that we're going to look through today are basically just solving problems using a different factoring method. So jumping in here to box number 1, here, now, I'll preface this. Here, I'm labeling what factoring method we're choosing for each of these different boxes on the test and on the review and kind of moving forward. It's just going to say factor completely or solve the equation, and it's not going to tell you how to factor it. You have to be able to identify what factoring method we choose. So looking at the first problem here in box number 1, anytime we're dealing with something that has just 2 variables in it, we're trying to figure out whether there's a GCF or if there's a GCF and difference of 2 squares or just difference of 2 squares. There's only those 2 methods to factor when there's only 2 terms. Now, just like with everything else, when we're trying to solve an equation, we want to get everything over on one side equal to 0, factor that left side or that non-isolated side, and then use zero product property, ZPP, to solve. So in this case, with number 1, 9x squared plus x, well, in this case, I can see that there's a GCF, right? They have x in common. So 9x plus 1 would be how that factors out. Right after I take that x that they have in common, 9x is left over, and positive 1. And now that I have that, I'm just going to split each of my 2 factors and set them equal to 0 using zero product property. So 0 is my first solution. 9x plus 1 equals 0. I would have to subtract 1 from both sides. That gives me 9x equals negative 1. So I divide by 9 on both sides, and x equals negative 1/9. Or if you're a decimal person, negative 0.1 repeated. So those are my 2 solutions for number 1. As always, if you're solving an equation, you can check your solution by plugging it back in. So if I plugged 0 in here, it should work. If I use negative 1/9 in there for x, it should also work. All right, take a look at number 2. Now I do have not only v in common between my 2 terms, but I also have both of them are multiples of 3. So 3v is my GCF. To factor that out, I'm looking for what I would multiply 3v by to get back to my original terms. So 3v times v would be 3v squared. 3v times negative 6 would give me negative 18v squared. And since that still equals 0, I can now split off into my 2 different options. 3v equals 0 and v minus 6 equals 0. So if I divide by 3 on both sides, 0 divided by 3 is still 0. If I add 6 on both sides, v is positive 6. So those are my 2 solutions for number 2. Hopping over here to box number 3, we're trying to factor and solve. So now I've got a trinomial on the left side. So my thought process for factoring a trinomial, still check for a GCF. In this case, there isn't a GCF. And then my next down the list, I have regular 2 parenthesis factoring. I can do that when my lead coefficient is just 1. So if it's just an x squared, or in this case, a t squared. So that's the only method I can choose to do here. You can also xbox factor if you want to, and that is something that you could use here. It's just going to be a little bit extra work. So I'm going to go ahead and use 2 parenthesis factoring here. I'm trying to figure out for my 2 parenthesis factoring what 2 things multiply to give me my last term, my c value, but add up to my middle term, my b value. So I know that my first thing in each of those parentheses are going to be a t and a t, but now I need to try and figure it out. So if you need to, like we did before, you can write out your factors of 35, in this case, negative 35. And when I'm choosing my numbers, because we're trying to add up to a negative 2, we're going to make the bigger one negative, the smaller one positive, so that when I add them together, they end up being negative. So we've got 1 and negative 35. That's too big. And then just 5 and negative 7. Ooh, we found it. There it is. So 5 and negative 7 add up to negative 2, but multiply together to give me negative 35. So t plus 5, t minus 7, because positive 5 and negative 7. Now that I have that factored, I can go ahead and split off, set each of those equal to 0, t minus 7 equals 0, and then I just solve each of them. So subtract 5 from both sides, t equals negative 5, add 7 on both sides, t equals 7. Another example of that, number 4. So now, again, first thing I should be checking with every single problem, even if it's not labeled as GCF, is check for the GCF. In this case, we do have a GCF. In this case, we've got 5 is a common multiple of both 5, 20, and 25. So if I factor that out, m squared plus 4m minus 5 has to equal 0. Now I'm factoring just what's on the inside of my parenthesis. So I'm trying to figure out what multiplies to get to negative 5, but adds up to a positive 4. So when I do that, my 5 sticks around. I'm going to factor that out into my 2 parentheses. I know it's m and m. That doesn't change. Well, changes my variable, but still just variable term and variable term. So it looks like since I want to be negative 5 when I multiply but add up to a positive 4, I know one positive, one negative. It's going to have to be positive 5 and negative 1, because 5 minus 1 is 4. 5 times negative 1 is negative 5. Now, when I go to solve, because my GCF didn't include a variable, it's not going to tell me an answer. Right? If you forget that and you say, all right, I'm just going to set each, I got 3 things multiplied together to give me 0. I'm going to set each of them equal to 0. 5 equals 0, m plus 5 equals 0, and m minus 1 equals 0. Well, 5 equals 0 doesn't tell us anything because there's no variable involved. There's no m that I'm trying to solve for. My middle, I have to subtract 5 on both sides to give me negative 5. And then my last one, I add 1 on both sides to get positive 1. So those are my 2 solutions, negative 5 and positive 1. All right. Heading over here to box 3. Box 3 is now going to be Xbox factoring and solving. So again, it's not going to be labeled that way on the homework or on the quiz, or the test, but you have to know what we have to do. So in this case, I check for a GCF first. Unfortunately, there's nothing common between 3, 8, and 35. So that means because there's a lead coefficient that is not factorable out, right? There's a lead coefficient, I have to use Xbox factoring. If you wanted to try and use 2 parentheses factoring, you can. It's just a whole lot of guessing and checking to figure out how those combinations are going to work. So Xbox factoring is going to be the easier of the 2 methods. So if we went ahead and did that, if we said, all right, for Xbox, I'm going to make my box over here. For Xbox factoring, I'm taking first term times last term. So 3 times negative 35 is negative 105. Feel free to use a calculator if you need to. And then my middle term was negative 8. So I'm trying to figure out what 2 things multiply together to be negative 105, but add up to a negative 8. So if you need to, again, make a list of your factors of 105. I'm going to skip ahead in my list a little bit just because I know 1 and 105 doesn't really fit. 3 and negative 35, I already know that doesn't work because those are my 2 original ones. So I'm going to look at the factors of 35. Let's maybe say 5. 5 in this case would have to be 5 times negative 21 would be negative 30 or negative 105, but that's too close together. That adds up to a negative 16. So my next one down the list would be 7 times negative 15, which that one does add up to negative 8. Right? That's my combination that works. 7 plus negative 15 is negative 8, but 7 times negative 15 is negative 105. So 7 and negative 15 are my 2 that work. I'm going to have to move this over here a little bit. There we go. So in my box, again, top left corner is always my first term. Bottom right is always my last term. And then those 2 that I just figured out, negative 15 with the variable attached to it and 7 with the variable attached to it, go in my other two corners. It doesn't matter which one's which. So from here, we're looking for a GCF somewhere, either in one of my two rows or one of my two columns. Maybe you see in this top row 3 and negative 15 have a 3 in common. G is also in common, so 3G would be right here. And now from here, we're just kind of figuring out what we have to multiply by. 3G times G would give me 3G squared. 3G times negative 5 would give me negative 15G. And that means then this has to be a 7 in order to get 7G or to get negative 35. So once I know that, now I know that how this factors would be G minus 5 times 3G plus 7, and that equals 0. So from here, ZPP to solve. I'm going to set each of these equal to 0. G minus 5 equals 0, and 3G plus 7 equals 0. So we're going to add 5 on both sides. G equals 5. Here we have to subtract 7 from both sides. 3G equals negative 7. Divide by 3 on both sides. G equals negative 7/3. So those are my two solutions, negative 7/3 and positive 5. For number 6, next one here. Here, I really wish that wasn't an 81. I wish it was like an 80, because then we'd have some GCFs happening here. But in this case, there is not. There is no GCF. So we're going to go ahead to X box factoring. We've got our X. Let's make it a little bit bigger. X. We've got our box. First times last, so 10 times 8 is 80. And we're trying to add up to 81. We've talked about this multiple times. If you're adding up to something that's bigger than what you're multiplying into, the only way that that's possible, is if it's the number and 1. Right? 80 times 1 is 80. 80 plus 1 is 81. So now I can go ahead to my box. First term, last term, and then those two that we just figured out. So now looking for GCFs all the way through. 10y squared and 80y, well, they have a 10y in common, which means this has to be y to get 10y squared. This has to be 8 to get 80y. And this has to be a 1 to get either 1y or 8. So factored out, I end up with y plus 8 times 10y plus 1 equals 0. And once again, we'll go ahead and split this off. Y plus 8 equals 0. 10y plus 1 equals 0. We subtract 8 on both sides to get y equals negative 8. We subtract 1 from both sides, and then divide by 10 to get y equals negative 1/10. Or negative 0.1 if you want to be a decimal person. But that would be how we would factor and solve using with Xbox factoring. Last box, challenge round. Now we're getting to be a little bit more difficult. So with this one right away, we recognize we've only got 2 terms, and they aren't even on the same side of my equation. So first step has to be get it equal to 0. So you can move either one of these. I find it easier to leave my squared term positive, so I'm going to rearrange this into 3a squared minus 27a equals 0. And now we're back to a problem like we've seen earlier. First step here, I check for a GCF. I see that they both are multiples of 3, and they both have a involved, which is nice. So here we've got 3a is my GCF. That's what they have in common, which means this has to be a to get back to 3a squared, minus 9 to get back to 27, minus 27a. That equals 0. I have a multiplication now, so ZPP tells me either 3a equals 0 or a minus 9 equals 0. I divide by 3, and I get 0. I add 9, and I get 9. So there are my two solutions. Last but not least, number 8, k squared plus 80 equals 18k. Once again, we're starting with something that it's not all together. So we're going to have to move that 18k over. Since it's positive 18k, we have to subtract it on both sides. So now I've got k squared minus 18k plus 80 equals 0. I have my choice here. I have k squared as my leading term. So if I wanted to use Xbox factoring, if you really like Xbox factoring, that's like old reliable. It'll always work. You're not going to have a polynomial that's factorable that doesn't work with Xbox factoring. Here, because it is a lead coefficient of just k squared of 1, right, I can do regular 2 parenthesis factoring, where I'm trying to figure out what factors of 80 add up to negative 18. Which it might be obvious to you, and if it is, that's awesome. If not, because we're going to add up to a negative, I know both of them are going to be negative. So negative 1 and 80, that's too big. Negative 2 and negative 40, that's too big. Negative 4 and negative 20, still too big. Negative 8 and negative 10, there she is. There it is. Yeah, so k minus 8, k minus 10, because negative 10 times negative 8 is positive 80. Negative 8 plus negative 10 is negative 18. So from here, ZPP to solve, k minus 8 equals 0, or k minus 10 equals 0. I add 8 on both sides to get positive 8. I add 10 on both sides to get positive 10. And there are my two solutions for the last problem. All right, so homework down there at the bottom of the worksheet, which is now at the top of your screen. It is a worksheet, so it is solving quadratic equations, which quadratic is just meaning x squared, k squared. Squared is my biggest degree. Solving those equations by factoring. And it is a worksheet. It is posted on Classroom. Those of you who are here in person have a hard copy of it as well. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.